Hello class, we're going to move on to our second Frayer model, and this is when we are given not just a point and a slope, we are given a table this time. And so when we're given a table, there are a few things that we can do. We can find the rate of change, or we can pick 2 points to find the slope using slope formula. So I'm going to actually pick 2 points and use slope formula instead. And the 2 points I want to pick are 0, 6, and 4, 0, because they're the easiest numbers because there's zeros involved. And so I'm going to label as x1 and x2 under the x column. Then I have y1 and y2 under the y column. Okay? And note, if you notice what they are, 0, 6 is your y-intercept, and 4, 0 is actually your x-intercept. So those will actually come in handy again. So let's put this into slope formula. So I have m is equal to y2 minus y1 all over x2 minus x1. So y2 is labeled for me as 0 minus y1, which is 6. Then x2 is 4 minus x1, which is 0. So 0 minus 6 is negative 6. 4 minus 0 is a positive 4, and I can reduce this to a smaller fraction, and I get negative 3 over 2. Okay, no decimals. We have to rise over 1 with this, so we need to have a fraction. So now I'm given a whole bunch of points and a slope, and several ways I can start this. I can start this using point-slope form or slope-intercept form because I'm actually given the y-intercept. Okay, so let's say we wanted to put it in point-slope form. Point-slope form, if I'm using 0, 6, y minus y1 is equal to m, parentheses, x minus x1. And remember, we said in our boxes, we're going to take the opposite of the point given. So I have y minus y1. The opposite of 6 is a negative 6 equal to m, which we found it to be negative 3 over 2. Open parentheses, x minus 0. Okay, because 0 cannot be positive nor negative. It is neutral. If I chose to do 4, 0, the x-intercept, I have y taking the opposite of 0, which is just 0. Then I have m, which is negative 3 over 2. Open parentheses, x, and then I have the opposite of a positive 4, which gives me a negative 4. So those are either of your point-slope forms. Now say I didn't have these, I can go to slope-intercept form. So we know slope-intercept is y equals mx plus b. Okay? So in this case, if I wanted to plug it in, we have y. We know what m is because it's negative 3 over 2. X, and then b is our y-intercept, which is 0, 6. So we put plus 6. So let's see if that's what we get if we were to solve and put it in slope-intercept form from point-slope form. So we have y minus 6 equal to negative 3 over 2, open parentheses, x minus 0. So I'm going to distribute. So I have y minus 6 equal to negative 3 over 2x plus 0, as if I was to distribute. And then I'm going to add 6 to both sides. So I do end up with y equals negative 3 over 2x plus 6. If I had to do the same thing with 4, 0, let's see if I end up with the same. So y minus 0 equals to negative 3 over 2, open parentheses, x minus 4. Okay, so I'm still going to distribute, but y minus 0 is just y. So I have y equals negative 3 over 2x. Then I have negative 4 times the negative 3. So if I had to write this like a fraction, I end up with positive 12 over 2, and I do end up with a positive 6. So these end up being the same answer. So if you're given the y-intercept and you find the slope, you can also start with slope-intercept form. Note, for point slope form, you can choose -2, 9 or 2, 3, and those are other options to write your point slope form. Now we have standard form. So standard form is ax plus by equal to c. So remember, we have to remove the x on the same side as y. Okay, so we have y equals -3 over 2x plus 6. So I'm going to add 3 over 2x to both sides. Not just 3 over 2, 3 over 2x. So we have the x value is first, so 3 over 2x plus y is equal to 6. But we're not done here. We definitely don't have a negative, so that's taken care of. But a can't be a fraction. So if a can't be a fraction, how do I clear the fraction? So here's, for this part, you're going to multiply by the denominator if ax is a fraction. This is also known as clearing the fraction, and you've done this before. So we're going to clear the fraction. So I'm going to take the entire thing and multiply it by its denominator, which is 2. And I'm going to distribute to each term. So 2 over 2 gives me 1, so I'm left with 3x. And then I have 2 times y, which gives me a positive 2y. Then I have 2 times 6, which gives me 12. So I no longer have any negatives, nor do I have fractions. And there's my standard form. And last but not least, we can graph. Now we can graph listing or plotting all of our points. We can graph by using our slope-intercept form. So either one is fine. But note, we do have our slope, which is -3 over 2, so we're going to rise or go down -3 and go over 2. Note, it is decreasing because our slope is negative. So our y-intercept is 0, 6. Then we can plot our other 2 points. Let's do -2, 9. Okay, and then we have 2, 3, and then we have 4, 0. We can keep going down to the rest. Our slope is going down 1, 2, 3, and we go over 1, 2. And there is our line. So that concludes our second Frayer model when given a table, writing all forms when given a table. Again, if you have any questions, please feel free to reach me at my tutorial hours on Thursdays from 3 to 5 during JAG overtime. Thank you.